This next section is very similar to the last section, except with one major difference. Both equations are not solved for any particular variable, neither x nor y. So let's focus in on this one here. The first thing we need to do is get y alone or x alone for one of these equations, so that it'll make us a little easier to solve. Now if I look at all places where I see an x or a y, the place that stands out as the easiest one is going to be this one, because there's no number next to it. When there's a number next to it, it means eventually I'm going to have to divide, and dividing means I might end up with fractions. So unless you're a huge fan of dealing with really awful looking fractions, I would say let's go for this particular y right here. So now looking at this equation, in order to get y alone, I see that it is added to a positive 5x, meaning that I need to add, to undo that, I need to add a negative 5x to both sides. And when I do that, I'm going to end up with 5x and negative 5x reducing down to 0, leaving me y equals 13 minus 5x, or 13 plus a negative 5x. So I've replaced this top equation here with this one here where it has y alone. I can now use that to solve it the way I did with problems in the previous section. So I'm going to go through these examples a little bit quicker, but I still want you to follow along and practice with them. Since I know what y is, I can plug it in to the place where I see a y in the other equation. So if I rewrite this equation, negative 3x plus 4, except when I get to y I write open parentheses and leave some space, equals 6. I'm going to trace in what I already calculated out to be y, 13 minus 5x. And then I'm going to keep going. I'm going to have to do my distribution right away, and remember that distribution is multiplication. So I multiply by both of those pieces. I have a negative 3x. Then I have the addition of 4 times 13. Plug that one in your calculator, you're going to get 52. Then I have 4 times negative 5x. 4 times negative 5x. And when I do that, I get negative 20x. So I do the 4 times the negative 5 to get negative 20, and then the x. And all of that is equal to 6. Next, I want to combine my like terms when I can. I see that on the left side, I have two terms that both have an x in it. And so those can just be added. I have a negative 3 plus a negative 20. So that's going to make negative 23x. Then I keep everything else the same. Next step, I want to get that 52 off of that side, so I'm going to add a negative 52 to both sides. So add a negative 52 to both sides. And that positive 52 and negative 52 go to 0, leaving me with just a negative 23x over on the left. On the right, either do that in my head or my calculator, and I get a negative 46. Final step, the negative 23 is connected to the x. We don't want to get rid of the whole thing, we just want to get rid of the negative 23 part, so we need to divide that out to undo that multiplication. We divide every single term by that negative 23, and once we do that, we end up with x equal to, plug this one in, and we're going to get a positive 2. So x is equal to a positive 2. Now, to take advantage of the fact that we have already gotten y alone, we can plug it into that equation right there to solve for y. So maybe draw a little line here. Y is equal to 13 minus 5 times what we know to be x, and that is 2. So I just rewrote exactly what I have above here, except I replaced x with a 2 because we know that x is 2. Y is equal to 13 minus 5 times 2, which is 10. So y is equal to 3. So now we have our solution. Our solution is the x term first, 2, the y term second, 3. So we have 2 comma 3 as our solution. We're going to use our second equation down here to be our check. So let's go ahead and plug it in to check it. I have a negative 3 times my x coordinate of 2 plus 4 times my y coordinate of 3, and that equals 6. So negative 3 times 2 is negative 6, plus 4 times 3 is 12. We think that's going to equal 6. Negative 6 plus 12 does in fact equal a positive 6. So we checked it. Good to go. Do one more example here. Similar to before, if we look at all the places where we see x and y, we're going to say which one is the easiest one to get alone, and it's going to be the one that has no number next to it, because that will help us avoid some fractions. So let's go ahead and figure out what do we need to do to get y alone on that very top equation. And the thing that's preventing it from being alone is the fact that it's added to a negative 4x. So let's add a positive 4x to make that go away, and do so to both sides. And when we do that, the negative 4x and positive 4x will add to 0, leaving us with just y on one side, and on the other side we have negative 20 plus 4x. So y equals negative 20 plus 4x. We're going to plug that in for what we know to be y on the lower equation. So that part right there is going to go in for y on our lower equation, since they're both equal to y. So let's write this out. We have 8x plus 2 times something, whatever y is, equals 24. We know from earlier that y is equal to negative 20 plus 4x, so we write that in. And then we have to keep on solving. So we start by distributing. Since 2 is being multiplied by that, we multiply it by each thing inside. And as we do that, we're going to end up with 8x, which we just carry down, plus 2 times negative 20 is going to be our negative 40, plus 2 times 4x, which is going to be positive 8x. And all of that is equal to 24. We want to combine our like terms. We have a positive 8x and a positive 8x, and that's not going to be 0. It's going to be a positive 16x. 8 plus 8 is going to be 16x. And then we have our negative 40 still over there, equal to 24. We continue on by saying I want to get that negative 40 off this side so I can get x alone. So I add a positive 40 to both sides. And then negative 40 and positive 40 are going to go away, leaving me with 16x equals 24 plus 40. That's going to be 64. The last step is to take the 16 and x and say they are being multiplied. I want x to stay, but I want the 16 to go. So I need to undo that 16 through the opposite of multiplication, which is division. When I divide both sides by 16, I get x is equal to 64 divided by 16, which is 4. So now I have x is 4. I'm going to take that part of my solution and I'm going to use that to solve for y. So that's going to go in for this x. Since I know x is 4, I'm going to plug it in right here. I have y is equal to negative 20 plus 4, whatever x is, and we know that that is 4. Y is equal to negative 20 plus 4 times 4 is 16. Y is equal to negative 4. So now we have our solution. X is 4, y is negative 4. So this is our solution. We just need to run our check as our last step. And to do our check, we're always going to use the equation we did not use. So since we used the top one to solve for y, we're going to use the bottom one as our check. So I'm going to take my 8x plus 2y, and we need a little more room here, is going to be equal to 24. So 8x plus 2y equals 24. We know x is 4. We know y is negative 4. So as we plug those in, we have 8 times 4 is 32, plus 8 times negative 4 is negative 8, and this should equal 24. 32 plus a negative 8 is going to be 24. That's what we expected. It checks. We are good to go. So always remember, get your one variable, use the equation to get the second one, and use the extra equation to check it. And once you've done all of that, you have completed the full problem.